And this is exam 2, physics 202, spring 2014. First multiple choice of farad is the same as, remember farad is a measurement of capacitance, so I know that C is equal to Q over V. Q is measured in coulombs, V is measured in volts, so that's coulombs per volt. That's D is the right answer. All right, these plate areas, separation of 5 parallel plate capacitors, and the separations are given. Rank them in order from least to greatest. So let's just first write them out. So capacitor 1 was A over D. Capacitor 2 is 2A over 2D. Alright, that's going to cancel and just give me A over D. Capacitor 3 is 2A over D over 2. That's going to be the equivalent of 4A over D because that 1/2 in the denominator comes up and flips into the numerator. Those 3. 4 is A over 2 over 2D. And that's going to be like A over 4D. And then the last one is A over D over 2, which is going to be the same as 2A over D. So these are our 5 different ones. First thing you can notice is that numbers 1 and 2 are the same, so we can get rid of a number of different options. Get rid of all those. So now we're just down to 2 options. We want to find the largest one. So let's see, this one's pretty big. Yeah, it looks like number 3 is the largest, so number C is the right answer. So that's our biggest. Our next biggest is this one. Our next biggest will be these two. So it's 3, 5, 1, and 2. And then this gives us the smallest, that's 4. So C is the right answer. 2 identical capacitors are connected in series, and 2, each identical reverse, are connected in parallel. Equivalent capacitance series connection is what of the parallel connection? So first, for the series, I say 1 over C plus 1 over C. That's 1 over 2 over C, which is C over 2. And then for parallel, it's just C plus C. That's equal to 2C. So the series connection is 1/4 that of the parallel connection. That is, C over 2 is equal to 1/4 of 2C. So D is the right answer. All right, consider the circuit. What is the charge on C2? I sent out a message actually showing y'all this, that this is the same circuit. All right, I have 1, 2, and 3 microfarads. And I want to know what is the charge on this capacitor. I know Q is CV. I also know that each of these carries 12 volts. So it's going to be 2 microfarads times 12 volts. Which is 24 microcoulombs. That's B. Parallel plate capacitor is a potential difference of 200 volts, then it's disconnected from the charging battery. If the area of the plate is not doubled, what is the evaluated voltage? When I'm disconnected from the charging battery, that means that my charge is held constant. And then I want to ask myself, what happens to the capacitance? Well, the area of the plates is doubled, so that means the capacitance is doubled. If the capacitance is doubled, the voltage is halved. So 200 volts now becomes 100 volts for number 5. But U denote charge, V potential difference. Excuse me. Q denote charge, V potential difference, and U denote stored energy. Capacitors in parallel have the same what? Well, we know capacitors in parallel have the same voltage, but it is not necessary for them to have the same charge. If they're identical capacitors, they'll have the same charge, but that's not absolutely necessary, and hence it's also not necessary for them to have the same energy. So only voltage. E is the right answer. Alright, all 3 capacitors are identical. What is the voltage across C3? Okay, well, we know that these 2 capacitors combined give us 2C, and since Q is equal to CV, a bigger capacitor will have a smaller voltage. So I know that I have to have 4 volts here and 8 volts here. So if I have 4 volts across this capacitor, that's also what I have across these 2 capacitors. So D is the right answer. Alright, 2 capacitors, CA greater than CB, are connected in series with a battery. Which of the following is true? Okay, so I know that they have the same charge. I also know, I'm just going to write this, we'll see if it's in the answers, but since CA is greater than CB, just like in the previous question, that means that I'm going to have a smaller potential. So that is VA is less than VB. And let's see how that comes up. There's more charge. Okay, we know that's not true because capacitors in series have the same charge. There's the same charge stored on each capacitor. That's true. There's the same potential difference across both capacitors. All right, we've already said that's not true. There's more charge stored on CA, so that's not true. So simple answer, just one of our basic rules, same charge. Current has units. 1 amp is equal to 1 coulomb per second, so that's E. Conventional direction of the current in circuit for the previous question would be which of these. I will give y'all this circuit in class, but it's going to look like this. All right, and that circuit is the conventional direction of current is coming off the positive direct terminal. It is the direction that protons would flow, and that is clockwise. Which of these has greater resistance, an incandescent bulb or a bathroom heater? 1,000 watts. That is going to be the one with the lower power. All right, you can think about it in this terms. P is V squared over R. I know that in a household circuit that V remains constant. The one with the greater resistance is the one with the lesser power. Or you can think about it that the one with the lesser power, that's the less dim, that's the more dim bulb, and so that means that it's restricting the flow of electrons more. Fewer electrons are going through it, and so the resistance must be greater and the power less. All right, current is a measure of which of these? Okay, it's not the speed. Remember, current is coulombs per second. How much charge passes a point at a given time? Speed would involve some distance, and we don't have any distances involved here. It's neither is it force, although we do talk about the electromotive force that pushes the current along, but it's not a measure of that. That's involved with the resistance as well. It's also not energy. That would be, voltage, which is an energy per charge. It is the amount of charge, right? And it's not E. That would be R. So it's just D is the answer. Potential difference across the resistor is doubled. What happens? Well, V equals IR. R remains constant because it's a resistor. All right. If V is doubled, that means that the current is doubled and nothing else. So A is the right answer. All right. Consider these. Wire A has 4 times the area and twice the length of wire B. We have rho L over A. It has 4 times the area and twice the length of resistor B. That means that it's going to have 1/2 the resistance. So C is the right answer. For certain diode, the current flows unimpeded in one direction. For current in the opposite direction, the resistance is very, very large. All right, so we did this plot actually. If I plot the resistance versus current, plus I, minus I, resistance is very low for current in one direction, goes very large for current in another direction. All right, let's do the free response. Consider this circuit and complete the table. All right, the hard part of this, of course, is drawing the circuit, redrawing the circuit. So I'm going to start here, and as I gave y'all a hint in class, I said always start off the positive side of the battery. It's a little more difficult to see coming off the negative side of the battery how this circuit splits up. All right, so it's going to look like this. I'm going to come down. I'm going to split into 2 branches. I split into 2 branches right here. Right. On that bottom branch, I'll see C1 and C2, and then I'll stop right there. Because after C2, it's going to come to this point, and then it's going to go back to the battery. And then on the top branch, I get C3, and then it'll break into another branch here, and I'll get C4 and C5. So I have C3, and then another parallel branch, C4 and C5, and then all that's going to come back together and go back to the power supply. All right, so this is the circuit we're dealing with, and let's put in our values here. Let's see, C1 is 4 microfarads. Sorry about that. C2 is 4 microfarads. C3 is 6 microfarads. C4 is 1, and 2 is C5. Let's just first find the equivalent capacitance. I can first combine these two, and I can also combine these two. This one is just going to be 1 plus 2 equals 3 microfarads. And then this one would be 1 over 1 over 4 plus 1 over 4, which is 1 over half, which is 2 microfarads, right? And then I'm left with this circuit. I have a 6 and a 3. Hopefully you're starting to see some common numbers popping up here. And then I have a 2 microfarad capacitor there. Now I combine these two. I get 1 over 6 plus 1 over 3. And that's equal to 2 microfarads. And then I have a 2 and a 2 in parallel. Remember, these are hooked up to a 12-volt battery. And the equivalent of that is going to be 1 over, or excuse me, 2 plus 2 is equal to 4 microfarads. All right. So my equivalent capacitance is 4 microfarads. And I have 12 volts here. That means that I have 12 volts here, and I have 12 volts here. So let's see, what can we posit first? Well, if I have 12 volts across this capacitor, that's the equivalent to these two capacitors. That means that I have 6 volts here and 6 volts there. So let's go ahead and write in for C1 and C2. I have 6 volts and 6 volts for both of those. We'll come in and fill in the charges in just a minute. Now, if I have 12 volts there, that means I have 12 volts across these two capacitors. Now, I could find the charge, and the charge across this capacitor would be CV, which is 24 microcoulombs. And then for each of these, I could say V is Q over C. Right? 24 over 6 would be 4 volts. 24 over 3 would be 8 volts. Right, so that's 4 volts for C3. So let's go and put that in. 4 volts for C3. And if I have 8 volts across this capacitor, that means I have 8 volts across both of these capacitors because they are in parallel. So if I have 8 volts there, that's C4 and C5 are both 8 volts. Alright, and then that's it. So now we just need to fill in the numbers. For each of these, I'm just going to say, for example, C1 V1 is equal to Q1. C1 was 4. 4 times 6 is 24 microcoulombs. For C2, it's likewise going to be 24 microcoulombs. For C3, which was 6 microfarads, 24 microcoulombs. And we get 8 and 16 here. Just multiplying the voltage times the capacitance of those individual capacitors. Two capacitors are in series. Each has a plate with 0.006 meters squared, separated by 1.77 times 10 to the minus 8. One of them has a dielectric constant with a constant of, this should say 2 actually. Now, what is the equivalent capacitance of these capacitors? So first, I just want to calculate what is C without the dielectric. That would be C1. Epsilon naught A over D. 0.85 times 10 to the minus 12. What's that? Farads per meter. Times the area. Which is 0.006. If I put those numbers in, I get a nice even value. Let me just double check it though. Yeah, I get 3 times 10 to the minus 6 are 3 microfarads. And then if I want to know C2, it's just going to be kappa times all of that. So I'm just going to say kappa times C1 because it had the same dimensions. And so it's going to be 6 microfarads. And then I have those two in series. I have a 3 and a 6 microfarad to find the equivalent 1 over 3 plus 1 over 6. Of course, that's equal to 2 microfarads. So that's the answer to the first question, is 2 microfarads. And then if they're connected to a 10-volt battery, what is the charge on each? Well, they're in series, so they're going to have the same charge, and they will have the same charge as the equivalent capacitance. So if they're in series, 10-volt battery, 2 microfarad, it's going to have 20 microcoulombs. That is Q equals CV. Q is equal to 2 microfarads times 10 volts, or 20 microcoulombs. So both of them will have 20 microcoulombs. Right, if you remove the dielectric, does the charge on each capacitor decrease, increase, or stay the same? All right, so if I remove the dielectric, the real question is, what is going to happen to this equivalent capacitance? All right, so let's just look at it. So let's say we now have a new circuit with a 3 and a 3 microfarad capacitor. So my equivalent is going to be 1 over 3 plus 1 over 3. That's 1 over 2/3, which is 3/2 microfarads. So my equivalent capacitance, when I remove that dielectric, goes down. My equivalent capacitance goes down. That sort of makes sense. Like if I reduce the capacitance of one of the capacitors, then my total capacitance is also going to decrease. And if that capacitance decreases, then we know that charge is equal to C times V. So if C decreases, Q is also going to decrease. So the answer for both of these is going to be decrease. Your bathroom heater has a power of 1200 watts and 120 volts. What is the resistance? What is the current? All right, let's start with B here. I know P is 1200 and V is 120 volts. So I is P over V. That's 1200 is 10 amps. All right. And then I can do A from Ohm's law. There's some other ways you can do this, but I chose to do it this way. If I want to know R is V over I, which is 120 volts over 10 amps. So that's, what, 12 ohms? Another way you could have done this is you could have said P is V squared over R, and then solve for R is equal to V squared over P, which is 120 squared over 1200, and that would also equal 12 ohms. Just double check that. That doesn't look right to me. Yeah, 12 ohms. Okay. So that was part A. And then if the heater runs for 3 minutes, what amount of charge travels through the heater? So I know the current is 10 amps. I just want to know the charge. Q is equal to I times T. That is 10 amps. Was it 3 minutes? Yeah, 3 minutes, which is 180 seconds. So that's 1800 coulombs. And then finally, Entergy charges 10 cents per kilowatt hour. How much does it cost to run this heater for 2 hours? This is a matter of basically dimensional analysis. We have, what was our power? Yeah, 1200 watts. That's 1.2 kilowatts. I'm going to multiply that by 10 cents per kilowatt hour. So that gets rid of the kilowatts here if I multiply this. And then if I multiply it times the number of hours, which was, it was running for 2 hours. No, it's 24 cents, right? Yeah. So it's 24 cents. It doesn't seem like that much, but if you do that all month, you know, that's $10 or $15 worth of your electric bill. So, all right, well, about $10. A couple more questions. These are pretty straightforward. These are largely, basically from the homework. Here I have the length of a rod. There's the radius. I have the resistance. What is the resistivity of the metal? Well, resistance is rho L over A. In the course of this, I'll need to find the area, pi r squared. So I'll go and do that. Pi times the radius, which is 1 centimeter, so that's 0.01 meters squared. And I get an area of 0.0003. So that's my area. And now I'm looking for the resistivity. Is going to be RA over L. Just solving this for resistivity. as 3.2 times 10 to the minus 5 ohms. The area I've already found. And the length was given. The length was 0.2 meters. I get 4.8 times 10 to the minus 8. This is in ohm meters, and that was actually the answer for the second part. What are the units of this? All right, one more question. This was a basic circuit. We did this one in class, actually, I think. First, I want to find the equivalent capacitance. I combine these two, 1 over 1 over 3 plus 1 over 6. That's equal to 2, so I replace that with a 2 microfarad capacitor. And then the equivalent is going to be 2 plus 2, which is 4 microfarads. All right, I know that the voltage across here is 12 volts because it's in parallel, so I have 12 volts. I can go and find the charge, too. Just say 12 times 2 is 24 microfarads. And then up here, as we've done before in a previous problem, so I'm just going to do it quickly here, I have 8 volts here and 4 volts here. I'll go and do it here. So I can find the equivalent charge. It's CV. This is going to be the charge on this 2 microfarad capacitor. That's going to be 2 times 12, which is equal to 24 microcoulombs. And then, for example, on C1, I can say V is Q over C. That's going to be 24 over 3, which is 8 volts. And a similar thing over here, giving me 4 volts. So C1 gets 8 volts, C2 gets 4 volts. And then Q1 is going to be 24 and 24, as we've already found. That one should have been pretty easy for you. We did that one in class. We've done several that are very similar to it. All right, that's the end.